Okay, so we've kind of gotten to something that I find really interesting, and that is our ability to shift around polar curves. The problem with, well, it's not a problem. The way that polar is based off of, what polar is based off the idea that you're going to describe the curve based on the angle you rotate from the positive x-axis, which we're calling the polar axis, and the distance you are from the origin. The origin. What we want to be able to do is take the origin and move it around, right? And we kind of know a way to do this, and the way we're going to do it is we're basically going to use parametric equations. And what we'll do is probably just play around a little bit. Maybe, I think I'm going to use the inspire, but let's get the idea down first. So, excuse me. How does one convert a rectangular point xy to polar? So this is, it might feel like a weird question, and maybe you don't immediately think like, oh, I know how to do this. But we've been saying over and over again that x is r cosine theta, and that y is r sine theta. Okay, so how's that going to help us? Well, most polar curves are solved for r, so they're usually solved for r, right? So we get r equals like f of theta, some kind of function of theta. Well, what if we combine these two ideas? So if you look at the way we're converting and you think back to parametric equations, we have x is r cosine theta, y is r sine theta. Well, what is that? What is that in parametric? This is a circle. So it looks like we're going to be able to do something with this, because if x is r cosine theta and r is equal to f of theta, some polar function, I can actually just replace that. I can just take this r and replace it with this. And then I can do the same for y. And then if I graph parametrically, you'll see that we're going to get the exact same thing. And once we have the parametric version, then we can shift it left, right, up, down, by basically changing h and k for like the circle equation that we just found. So that's what we have in this box here. If r equals f of theta, then the polar curve can be written parametrically and translated using the equations x is h plus f of theta cosine theta, and y is k plus f of theta sine of theta. So what I want to do is I'm going to switch over to the inspire and just kind of like play around with it for a little bit. So let me see. I need to share the inspire with you. Okay, so we get this. I have no idea what this looks like on the video. Hopefully my face isn't obscuring the whole thing. I hope that that's the case. So what I'm going to do is first I'm going to change something to polar, right? So I'm going to go menu, graph. Let me get the cursor kind of out of the way. So it's menu and then 3, and then I want to change to polar. So let's say I just graph, let's do a rose curve. Let's do 2 cosine of 3, and then I'm going to write theta. You can press the pi key a couple times, and you'll get theta. So we have this. Okay, so that's perfectly good. Okay, let me switch now. So on the same page, I'm going to switch menu 3. I'm going to switch to parametric. And then that curve is sitting in R1. So I'm going to type R1 of t now, because I'm in parametrics, cosine of t. And then R1. R1, by the way, should be in the var key. So if I press var, you can see that R1 is available. And then sine of t. I'm going to press enter and just see what happens. You can't tell that anything happened, right? But if I hit tab, it's actually 2 different curves here. So the advantage of the parametric one is I can actually go in here and I'm going to do like 6 plus this, and then maybe do 5 plus this, right? So now the origin, the center of our circles, has been shifted to the point 6,5. But once we get to 6,5, we're just going to make the normal polar curve with everything relative to 6,5. So let me hit enter and you can see what I mean. So we get the same thing, but it's now shifted. And then we can, so you can start doing whatever you want, really. Cosine of t, and then do like 3 plus r1 of t sine of t. And now we can graph like a bunch of them if we want, or make a picture or whatever you want to do. So this is the idea behind this. We're going to have r as a function of theta, so that's our polar curve. Then we're going to rewrite that as if we're writing a circle in parametrics, and we're just going to shift the center wherever we want, and that'll be where the origin goes, and you can take your polar curves and move them about. So let me see what hopefully you just have the questions in front of you. I'm going to be bouncing back and forth here for a second. Let me see. So the next thing we want to do, rose curve with 5 petals, one of them directly east of the center with the origin shifted to -6, 2. So let me pull this up on my other display so that I can read that. And then I'm going to switch back to the Inspire and play around with it and see if I can get that. So back to the Inspire. Here we go. All right, so I'm going to start a new problem. So doc 4.1. I'm going to add a graph page. And I'm going to go straight to the parametrics because I think I got this. Menu 3, and then parametric. Okay, so rose curve, 5 petals, one of them directly east of the center. So east is to the right, which means on the positive x-axis. Any rose curve with a petal on the x-axis will be a cosine curve. So I'm already thinking that I'm going to use cosine something. You know what? I am going to use polar for 1 second because I want to be able to just use R1 instead of typing it. So let's see. I'm going to go with 4 cosine of, I want 5 petals, so 5. And then I'm going to type theta because it works. I'm going to press enter and see if this is doing what I want. That's definitely what I wanted. Okay, so now I want to take this and shift it to -6, 2. So I'm going to press menu and let's go back to parametric. And then I want -6, 2. And it's going to be R1 of t because we're in parametric mode. And then cosine of t plus R1 of t sine of t. And press enter. And you can see now the center is -6. Let me trace. Menu 5, graph trace. I want the other graph. Okay, so when theta is equal to 0, I'm at that right point. Ooh, when do I get to these things? So I want, oh man, the period is 2 pi over 5, which is, and then I got to divide that by 4. Pi over 10 is an increment. So I think that I get there at pi over 10. At pi over 10, I'm at -6, 2, which is exactly what I wanted. Okay, so do you need to see me write this down? I don't know. I guess I will switch to the iPad and write it. So let me switch, a lot of switching, screen mirror. Here we go, it's back. All right, so the equation that I came up with, I think, was x is going to be, y is going to be. So -6 and 2, that's our center. And then I think I did like plus, the value of a for your rose curve doesn't really matter. So I'm going to make it 1 when I handwrite this. I'm just going to go with cosine of 5 theta. So that's r. And then I have to do cosine theta, because that's how you convert it to parametrics, right? It's like r cosine and r sine. So then plus cosine of 5 theta. So this part will always be the same. The r thing that you're subbing in, always the same for both. And then sine of theta. Okay, so that's pretty good. And now what I want to do is see if I can figure out the other ones. So rose curve with 16 petals, one of them directly north of the center with the origin shifted to 8, -3. So without really doing anything, I know that it's going to look like x equals y equals, it's going to go 8, -3. So I don't really know what I'm filling in yet, but I'm going to put plus f of theta plus f of theta, because that's what r is going to be. And then this will be cosine of theta, and this will be sine of theta. So now I need to work out a rose curve with 16 petals, one of which is directly above the center, directly north of the center. So in my mind, to make that happen, I'm gonna need to get like 4 petals in each quadrant. But if there's gonna be one of them here, that means half of that petal is going to be in the first quadrant and half in the second quadrant, which means I probably also, so half to get a full one, I'm going to need this. And then this is a terrible drawing, but it's going to be like that, I think. That is just an awful drawing. But I think that I'm going to go with cosine, right? So what should I do here? I'm going to erase that because I kind of need the space. Not really sure how this eraser works. You just like get close to it and it erases things. So I think that I'm going to go with f of theta is going to be cosine of 8 theta. So I guess let's go back to the inspire and see if that is true. So I'm going to add a, let's see, I'm going to add a problem, I guess, so that I can start over. Graph, menu, change this to polar first, and let's go with like, just to like make it a little bigger, I'm going to go with 4 cosine of 8 theta. Okay, and I need to like count those, I guess, kind of. Stop. Okay, so there's definitely 3 like in the interior, and then there's half and half. So 4 per quadrant, there's 16. That's what we were looking for. So then I'm going to add another graph page. I'm going to make this one be parametric. So menu 3, 4. So it's 8 plus r1 of t cosine of t, and then -3 plus r1 of t sine of t. And you can see that we have done it. So so we're running into that issue though where the default theta max or t max is actually less than 2 pi, which means that you don't close if you're counting by 0.13. It's one of those like rounding errors that you run into. If you make it 6.3, closes it and it looks better. Okay, so I'm going to stop this here and come back and do more of these.